Okay, so today we're going to be looking at atomic structure, but before we can move on to what an atom looks like, we first have to know some definitions. So the first definition is an element. So you define an element as a substance that can't be further divided into anything simpler, and it's only made up of one type of atom. So an example would be copper. Copper is a metal that is only made of copper atoms. That's the only thing in there, so it makes up an element. Oxygen is also an element, but you can see there's O2. So that means it's an oxygen molecule, but it is still an element because it's only made up of oxygen atoms. They just like to join together and be diatomic. A compound is a substance that is formed by a chemical combination of two or more elements, and they're always in a fixed proportion. So when we chemically make something new from our elements, such as H2O, we've made water from hydrogen and oxygen, which we know are both gases. When they combine in that ratio of 2 hydrogens and 1 oxygen, it then makes a new compound. Or sodium and chlorine together make sodium chloride. They are chemically bound, so they are a compound. A mixture is a substance that is made up of 2 or more elements or compounds. They are not chemically bonded together though, so we can physically separate them. Okay, so anything that can be physically separated out into either elements or compounds, we say is a mixture, such as sand and water. Okay, water, H2O, sand is silicon oxide. We can easily separate sand from water because they are not chemically bound together. So anything that we can physically separate, we call a mixture. So it's important to know the difference between an element, a compound, and a mixture. But we also need to know what is in specific atoms. So if we look at the structure of an atom will consist of a nucleus in the center. So if we have to draw that out, I can have a nucleus in the center, and inside there are protons and neutrons, and then around that nucleus I'm going to have what I call energy levels, and the energy levels are going to hold the electrons. So that would be your basic structure of an atom. The protons in the nucleus, they are your subatomic particles that have a relative atomic mass of 1, and they have a charge of +1. So I can say that those are all little pluses. And the proton number is what makes the element what it is on the periodic table. Along with protons, I have neutrons in the nucleus. So the neutrons are also there in the middle, and they are subatomic particles with a relative atomic mass of 1 and a charge of 0. They are neutral, that's why they are neutrons. And then the electrons are the subatomic particles with a very, very tiny relative atomic mass of 1/1840. So it's very, very small in mass, it's almost negligible. And they have a charge of -1. So the electrons will then be sitting in the energy levels around the outside. So that would be our basic atomic structure. So nucleus with protons, neutrons, and then electrons all around the outside. So it's important to know these relative charges and the relative masses, because you can get a question like this where they ask you to fill out the table. They will usually give you the relative mass of the electron, but if we have to fill out the table for the rest, the neutron's relative charge, it's always going to be 0. Okay, and its relative mass would be 1. The proton's relative charge would be +1, and its relative mass would be 1. Okay, so if you have to fill out the table, you've just got to remember that a neutron is neutral, so it's 0. A proton is positive, so it's +1. And then the masses for each are 1. Okay. If you have to look at the periodic table, you will usually have a key that will give you atomic number and atomic mass. So those can be with either way around. You just need to read the key to know which one is the atomic number and which one is the atomic mass. But that's for every element on the periodic table. The atomic number is the number of protons in the nucleus of an atom, and it will determine the number of the element. So the number of protons will never change for a specific element. Okay, then the mass number, also called the nucleon number, is the total number of protons and neutrons that are in the nucleus together, combined. So on your periodic table, you will always have your symbol for your element, and then you will have atomic number and mass number. The atomic number is always the smaller one. So no matter which way it's written around, the smaller one is always going to be the atomic number, and the bigger one is going to be the mass number. Okay, now you've got an atomic number, which is the number of protons, and then a mass number, which is the total number of neutrons and protons together. So if you have to calculate the number of neutrons, the neutrons will always equal the mass number minus the proton number. So in this case, my number of neutrons would be 23 minus 11. So if I say 23 minus 11, I should get that my number of neutrons would be 12. So you will always just look for the mass number, look for the atomic number, and it's usually the bigger one minus the smaller one will always give you your neutron number. So your types of questions that you're going to get would be literally to deduce the number of electrons, neutrons, and protons in the following symbols. So in this case, like I said, there's no key, but you always know the smaller number is always going to be the proton number, and the bigger number is going to be the mass number. So if I have to fill this in, the number of protons, I look for the smaller one, would be 11. The number of neutrons is going to be 23 minus 11, which is going to be 12. And then my number of electrons, because there is no charge here, the number of electrons always equals the number of protons. So the number of electrons is going to also be 11. As soon as I add a charge to something, so for example here, if I add a plus, that means it's lost one electron. So then the number of electrons would be one less, so it would be 10. If I add a minus, it would be gaining electrons, so it would be one more. Okay, but if it's neutral, it's always going to be the same. If I look at the next example, I've got potassium, so I've got K, and I've been given 40 and 19. So I know 19, the smaller number, is going to be the proton number. The neutron number is going to be the bigger one minus the smaller one to give me my total. And then because there is no charge here, the number of electrons equals the number of protons, so it would be 19. Okay, so those are the types of questions you can get if they ask you individually. What they can also ask you is they can ask you to fill it out in the form of a table. So you have to complete the table by filling in electrons, neutrons, protons, and symbols for what's missing. So if we go row by row, the first one, I have calcium. They've already filled in the electrons and the protons. So the protons there, the smaller number being 20 matches. The electrons, because it's 2 plus, there is 2 less electrons because it's lost 2 of them. And for the neutron number, I've got to just take the bigger minus the smaller. So I would say 42 minus 20. So that gives me 22 neutrons. For the next one, I've been given chlorine, and I need to fill in the number of protons and electrons. So the proton number, the smaller one, is 17. There is no charge here, which means the number of electrons must be the same. So it is 17. And then the last one is missing the symbol. So I need to first find protons. Protons is 16. Remember, protons never changes. Protons tell me what is on the periodic table. So I look on my periodic table and I find 16. And I know that it is sulfur. So that gives me the symbol that I need. So I know I have to have sulfur over there. Now, sulfur, I'm going to fill it in the same way that all the other examples given to me are. So the proton number must be at the bottom. So I'm going to fill in 16. And that means at the top, I need to fill in the mass number. And the mass number, I'm going to take the neutrons plus the protons. So I'm going to say 16 plus 16, and I'm going to get 32 to fill in at the top for the mass number. And then I need to look at how many electrons are there. Is there going to be a charge? So in this case, 16 protons and 18 electrons. They are not the same. So there are more electrons than there are protons. So I have gained them, which means they need to be minus. And there are 2 extra. So it needs to be 2 minus. So that's how I get the charge. You always just have to look, is the electron number higher, then it's minus, or if the electron number is lower, then it's plus. Okay, so those are the types of questions that you would get to fill in for our atomic numbers and mass numbers based on our symbols from our periodic table. But they could also ask you to fill in the electron configuration. So, for the electron configuration, I will always have the nucleus in the middle with my specific symbol that I'm looking at. And then I told you before, all of those electrons are arranged in energy levels. So when it comes to electron configuration, let's find one on the periodic table. So let's say that I am looking at silicon. Okay, so silicon, if it is neutral, would have 14 electrons. So with the nucleus in the middle, let's say I'm now going to draw silicon. Sometimes they don't put a circle around the nucleus. If you do, then you leave that blank. If not, you can just start straight in the middle with your electrons. So we start closest to the center, and the very first energy level will have 2 electrons. We can represent them by X's or we can represent them by dots. X's are just easier to see. So the inner one will have 2 electrons. Then we jump to the next energy level after that. The next energy level after that will have 8 electrons. So we start by saying there's 1 electron, 2, 3, and 4. We always go in a pattern like that because we always draw singles before we make pairs. So there's 4, 5, 6, 7, 8. Okay, so that makes one full energy level with 8 electrons in it. So we start with 2, then 8, and then the next one can also have a maximum of 8. But remember, we are dealing with silicon, and silicon only has 14 in total. So I've drawn 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've already drawn 10. So now the last 4 to get to 14, I'm going to say 11, 12, 13, 14. So that would be drawing the electron configuration for silicon. So it's always going to be 2, then 8, then you can have 8, 8, 8. But we count them up to make sure that we have the right number based on the periodic table. So this is how I draw it. If I have to write it, to write the electron configuration now, I simply have to just total each electron in the energy level. So in this energy level, there was 2. So I can say silicon's electron configuration equals 2. Then I put a comma to separate the next level. Then that next energy level has 1, 2, 3, 4, 5, 6, 7, 8. So I say 2, 8, then I put another comma, and then my outer one has 1, 2, 3, 4. So my electron configuration written is 2, 8, 4. So that's all we have to do. We just have to remember there is always 2 in the inner shell and then 8 in every shell after that. But remember, they are singles first before we make pairs. So your types of questions. If I have to draw the electron configuration for sulfur, I look up sulfur on the periodic table and I find that it is 16. So I need to draw 16 electrons. And they did the first 2 for me already. So that's 1, 2. Then I say 3, 4, 5, 6, 7, 8, 9, 10. Then I move to the next shell. 11, 12, 13, 14, 15, and 16. So there's my total. If I had to write that, instead of just drawing it, I would say 2, 8, 6. Okay, for my next one, they wanted magnesium. So I look at magnesium. Magnesium is 12. So to draw it out, again, they did the first 2 for me. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So to write that out, 2, 8, 2. Okay, what you will also always notice for the electron configuration is the last number that you have will always correspond to the group that it's in. So everything in group 1 has 1 electron on the outside. Everything in group 2 has 2 electrons on the outside. Everything in group 6 has 6 electrons on the outside. So that last number always corresponds to the group number that you have, because that tells you how many electrons are in the outer shell that we have in our electron configuration. Something else that you might see is you might see some multiple choice questions like this, where they want to know which of these atoms from A to E is an atom that only contains 2 shells of electrons. So remember, each circle that we have is a shell. So 2 shells would be 2 circles that contain our electrons. So this one, for example, has 1, 2, 3. That one has 1. This one has 1 and 2, so that's what we're looking for. Then this one's got 1, 2, 3, and 1, 2, 3. So our answer would be C, because that's the only one with 2 rings. Okay. Then I could have isotopes. So an isotope is something that will be an atom with the exact same proton number, because it will be the same element, but it'll have a different number of neutrons. Okay, so that means the mass number will be different. So an isotope could be, for example, hydrogen. Hydrogen always has the atomic number 1. Okay, so the regular atomic number is 1 and the regular mass number is 1. So this would be my regular hydrogen. But sometimes I could have more neutrons, which means the atomic number still stays 1, but the mass number could be 2, for example. Okay, those are isotopes of each other. Okay, so isotopes will always have a different mass number, so you must be careful when you're calculating your neutron number in your tables, because sometimes they can change it. Don't always rely on the periodic table, because you could have isotopes. So, isotopes of the same element will always have the same chemical properties because they have the same number of electrons. Okay, you must be careful with that. Chemical properties relate to the number of electrons. The physical properties can differ because of the different mass numbers. Okay, so isotopes will always react the same because they still have the same number of electrons. Unless there are ions, everything will always have the same number of electrons. So unless you see pluses and minuses, the electron number is the same as the proton number. Okay, and some isotopes are radioactive because the nucleus becomes unstable when you add extra neutrons, and those we are called radioisotopes. So, the types of questions we could get for an isotope. I have two different isotopes that are given to me, and they need you to explain how these isotopes are the same and how they are different in terms of protons, neutrons, and electrons. So, because they are the same element, they will always have the same number of protons. And because there are no charges, they will also have the same number of electrons. How they are different is they are different in the mass number, so they are different in the number of neutrons. Okay, then explain why they have an overall charge of 0. So there is 0 charge there because the protons and the electrons are the same. So the pluses and the minuses cancel each other out. So whenever anything is 0 or neutral or there's no charge, we always just say the protons equal the electrons, because the pluses equal the minuses. And then a third part to that question is to explain why the isotopes have the same chemical properties. So the chemical properties are always because of the same number of electrons. Okay, so both of them have the same number of electrons. That is why they have the same chemical properties. So after we know what an isotope is, we can use that information because we can sometimes calculate the relative atomic mass. So all of these masses on the periodic tables have been calculated for us. Okay, because the relative atomic mass is the average mass of atoms of an element on a scale where the carbon-12 atom has a mass of 12 units. So there's carbon, it's carbon-12, and its mass is 12 units. So they took everything on this periodic table and they worked out its mass by comparing it to carbon-12. They can also use a mass spectrometer, which is a machine that can measure out the exact amount of each of our different types of isotopes. So I can take isotopes and I can measure out how much of each isotope I have, and I can calculate an atomic mass based off of the answers it gives me. So I can get a little graph like this or a table that tells me the percentage that I have of a specific size atom with specific mass, and with that I can calculate the atomic mass, because the atomic mass always has the same formula. It's always going to be the mass that I have times its percentage, all added up together, and then I take it and divide it by, if I add up all the percentages, it should come to 100. Okay, so if I have to look at this example, I'm going to take the mass that I have, which was 6, times its percentage of 7.5, plus the next mass I have is 7 times its percentage of 92.5, and I'm going to divide that whole thing by 100. So if you type that into your calculator to get your answer, so you have 6 times 7.5 plus 7 times 92.5, and then I divide that by 100, I end up with a final answer of 6.925 as my atomic mass for this element. So that would be the masses that you see on those periodic tables. The IG periodic table is nicely rounded off, but most of the time they have decimal places, and that's because those masses were calculated. But you know that you can't get a 0.9 of a neutron, so it will usually be whole numbers on the periodic table or in real life, but to calculate we can have decimals because we just work it out based on the abundance of isotopes. So they can give it to you in a graph form like that, or I could put these numbers in a table, but the formula still stays the same. Mass times percentage, all added together, divided by 100. And that will be the atomic masses that we will find on the periodic table, but we've worked them out. So if you get a question like that where they ask you about the relative atomic mass, don't just look it up on the table, do the calculation to get the answer. But that's basically everything that we need to know about atomic structure, electron configuration, and isotopes.